Let's do the domain and range before we decide if it's a function. The domain are all the x values. So in order, it's 2, 3, and 4. And you have to put it in set notation, so you need these braces on either side. The range is the collection of the y values. So just 2 and 3, and don't repeat the 3. So the range is 2 and 3, and you need those braces for set notation. Now let's answer whether or not it's a function. It passes the vertical line test. Oops, I'm sorry. These are them. There is no. The domain values are all unique. Because they're all unique, meaning all different, it is impossible to pair the same y value, which is a range value, with a given domain value. So if these are all different, then this is a function. The domain is the collection of all of the x values. So 1, -2, and 1. But don't repeat any values and put it in order. So -2, then 1. The range is the collection of all the y values. So in order, it's 4, 5, and 7. Now, if you look at this domain value is paired with a 4, the same domain value is paired with a different range value. So this is not a function. Let's do the domain and range first. The domain is the collection of all the x values. So the domain is 1, 2, and 3. The range is a collection of all the y values, so just 1. This is a function, and we know it's a function because all of the domain values are unique. So if all the domain values are unique, it has to be a function. Okay, let's do the domain and range first. The domain is the collection of all the x values, so just 2. The range is the collection of all the y values, so 3, 4, and 5. This is not a function because we have a domain value that's paired with multiple range values. So this a domain value is paired with a range value of 3. It's also paired with a range value of 4 and 5. So this is not a function. I guess another way to look at this is if you have more range values than you have domain values, you're not going to have a function when you're talking about ordered pairs. So that's why these two are not functions. But this one is because you're allowed to have more domain values than range values. So this one is a function. Because these are shown graphically, we can answer this question first. If we do the vertical line test, which means if we put a single vertical line down anywhere on this graph, it cannot intersect in more than one spot. So this is a function. The domain is how far left it goes. This is pointing to the left forever, so negative infinity. This is pointing to the right forever, so positive infinity. The range is how far up and down it goes. This is pointing downward for forever, so this is from negative infinity to this is pointing upward for forever, so that's to positive infinity. First of all, this is a function because a single vertical line could not be placed in a way that it could intersect this in more than one spot. So this is a function. The domain is how far left we go, and we're going back to -3, and that filled in dot means we use a bracket. And we're going continuously, so we have to put it in interval notation because there's a line between all of our points. And we're going all the way up to +3. And again, we use a bracket because of that filled in point there. The range is how far down we go. We can go down as far as -1, and it is hitting the -1, so we need to use a bracket. And we're going up as high as 1, 2, 3. So the range goes to +3. And again, we have to use a bracket because there's a filled in circle there. This is not a function because a single vertical line could be drawn so that you intersect in more than one spot. So this is not a function. The domain is how far left you go. This is pointing to the left, so it's pointing to negative infinity. All the way up, and we have to put in interval notation because this is a continuous line, but it goes all the way up to 1, 2, 3, 4. And we have to use a bracket because it is hitting the 4. There's no open circle there. The range is how far down it goes. This is pointing slightly down, but it never stops going down. So this is going down to negative infinity. And this is pointing slightly up, and it will never stop going up. So this is going to positive infinity. First of all, this is a function because there is no single place that you could put a single vertical line in that will intersect this in more than one spot. So this is a function. The domain is how far left you go. This is the furthest left point on the graph, which is negative 1, 2, 3, and we use a bracket because it's hitting that point. All the way up to, and this is the furthest right point on the graph, and it goes up to positive 2. And again, we use a bracket because it is hitting that spot. The range is how far up and down it goes. This is going down as far as negative 4. And this is the uppermost point, and it's going as high as positive 5. And we're using brackets because we are hitting those numbers. I'm going to use the intercept method. If I cross out the y, x is 2. If I cross out the x, y is 2. Because there's an equal sign here, I'm drawing a solid line when I draw this. Now, when I'm ready to graph, or shade, excuse me, I can either consider the x or the y. If I consider the x, x's go left, right. This is less than, so I'm shading to the left-hand side of this line. But I'm not going to shade yet because I need to graph this one and then do just the intersection. But I can put a tiny arrow to remind myself. By the way, if I did y's go up, down. This is positive, so you follow that arrow, you do the downside of this, which is still this side of the line. Okay, x greater than or equal to negative 1 is a solid line at negative 1. So I'll grab my ruler and put a solid line there. And x's go left, right. This is a positive x, and I'm going on the greater side, so I'm shading this side of this line. So I'm only shading the intersecting portion. So in other words, I want whatever is below this line and whatever is to the right of this line. So just this portion in here. And so when I go to graph it, I'm shading just in here. That's it. Now this is careful, this is an or, not an and. So x is greater than 2 is a vertical line through 2. So, and there's no equal sign here, so I'm going to draw a dashed line. So I'll draw a vertical line here, dashed. And I'm ready to shade on the right-hand side of this line, the greater side. Then y is greater than 3 is a horizontal line through 3. And again, there's no equal sign, so I'm going to draw a dashed line. And I'm going to be shading on the greater side of this, so the upper side. And because it's an or, I'm not looking for the intersection. I'm looking for anything and everything that could be shaded. So in other words, I'm doing everything to the right of this line, and everything to the upper side of this line. Now, if this was the and, I would have only included right here. But because it's the or, I'm including all of this and all of this. Because 2 and 1 go into 4, I'm going to use the intercept method. If I cross out the y, x is 2. So on the y, oops, I'll put a dot at 2. And then if I cross out this, negative y is 4, so y is negative 4. Because there's no equal sign here, I'm going to draw a dashed line. Now when I'm ready to shade, and I'm not ready to shade yet because it's an and, but this is a positive x, so x's go left, right. I follow this arrow and I'm going to shade the left side of this. If I chose the y's go up, down. This is a negative y, so you do the opposite of this. Instead of doing the lower side, you do the upper side, which is still this side of this line. So I'm shading over here, but I got to wait because I got to look at the intersection. This is slope-intercept form, so I put my y-intercept at 2. That's that. And then I rise 1 and run 2. There's no equal sign, so I'm drawing a dashed line. And this is up, down, so I'm going, there's a positive, so I'm going down. So I'm doing the lower side of this line. So I'm looking for this side of this line and this side of this line, which is just this portion in here. So the intersecting portion is just the portion in here. That's it. Okay, this is an OR, so I'm going to be shading everything. Because 3 and 2 go into 6, I'm going to use the intercept method. If I cross this out, 3x is negative 6, so x is negative 2. So I put a dot right there. If I cross this out, 2y is negative 6, so y is negative 3. I put a dot right there. Because there's an equal sign here, I'm going to be shading a solid line, not a dashed line. And when I go to shade, if I look at the x's, this is positive, so x's go left, right. I follow this, so I'm shading to the right-hand side of this. And by the way, if you could have done the y's, if you do the y's go up, down. This is positive, so you do the upper side. Y's go up, down. This upper side is the same like the right side. Okay, now, y is less than or equal to 1. This is a horizontal line that y is equal to 1. And it's solid because there's an equal sign. And so less than goes this way. So I'm shading everything to the right of this. So I'm shading all of this stuff. And I'm shading everything to the lower side of this line. So down here as well. Now again, if I was after the and, it would have just been this intersecting portion only. But I included this and this because it was the or. Okay, absolute value inequalities. Remember that when you have an absolute value that's less than a positive, you're going to have one interval, and you can use the sandwich method. So I'm going to take this out, and I'm going to sandwich that in between the negative and positive version of this. And then I'll solve for the middle portion by adding 3 to each section. And I'm going to get negative 1 plus 3 is 2. 1 plus 3 is 4. So these are y equals, and so they're horizontal lines at 2 and 4, and they're dashed. So I'm going to draw a line at 2, a dashed line at 2, and a dashed line at 4. And this is in the middle of these, so I'm going to have a single shaded region right in there. And by the way, I knew that I was going to have a single shaded region because this was an absolute value less than. Here we have an absolute value that's greater than a positive. So I know I'm going to end up with 2 shaded regions rather than just 1. So I'm going to have to set this up twice. I'll go x plus 2, and I'll leave this and this alone, greater than or equal to 2, and I'll put comma, and I'll go x plus 2, and then I'll flip both of these. So this is x is greater than or equal to, I'm subtracting 2 from each side. This is x is less than or equal to, and I'm subtracting 2 to get negative 4. So these are vertical lines, and they're going to be solid because of the equals, and we're doing one vertical line at negative 4 and one at 0. So a solid vertical line at negative 4, a solid vertical line at 0. Put arrows on either side. Now, greater than 0 is the greater side of this, so we're shading this side. And less than negative 4, here's our negative 4, less than is this side. So we're shading this area right out here. And it was helpful to remember and know from the very start that I was going to have 2 shaded regions. And so I knew to set it up twice. I knew that because we had an absolute value greater than. When you have an absolute value less than, you're going to have 1 shaded region. So you do it once using the sandwich method. For this function, f of 3, we find the 3 in the domain, not in the range. We're not looking at this. We find this one, and we pop out the corresponding range value, which is 4. Number 44 is this graph. The value of the function is the range value at the given domain value. So the domain values are x. So if we go out to 3, the corresponding y value is 1. So this is 1. Same like this. You go out to 3, which is this, the corresponding y value was 4. F of 2, here's the f function. F of 2 is we're going to put the 2 in for x. So this is equal to 2 times 2 minus 5. That's negative 1. This is the g function. G of 1 is we're putting in a 1 for x. So we have this is equal to 1 squared minus 1 plus 4. This is equal to 4. F of negative 5, this is the f function. We're putting in negative 5 for x. So this is 2 times negative 5 minus 5. This is negative 15. G of negative 2, we're putting in a negative 2 for x. So we're going negative 2 squared. And we've got to put it in parentheses because we've got to square the entire negative 2. That's going to turn that into a positive. Then we have minus a negative 2 plus 4. This is positive 4. This turns into a plus 2, which is 10. F of a plus 1, wherever you see the x, we're going to replace the entire x with a plus 1. So this is going to be 2 times a plus 1, that's our x, minus 5. We'll distribute this and get 2a plus 2 minus 5, and we'll combine these, so we end up with 2a minus 3. F of 1/2, we'll take a 1/2 and put it in there, so we have 2 times a half minus 5, which is 1 minus 5, gives us negative 4. Let's put this in slope-intercept form. I'm going to start by moving the 3 over, so we have negative 2y is equal to negative 3x minus 2, and then I'll divide everything by negative 2. So we're going to get y is equal to a positive 3 over 2x plus 1. So our slope is the number in front of the x. The slope of this is 3 over 2. This is already in slope-intercept form, so our slope is right there, negative 2 over 3. These are opposites, one's positive, one's negative, and they're reciprocals, they're flipped upside down. So because they're both opposite and reciprocal, they're perpendicular.